Hi there. Now this is a complete API for the basic to-do application, and this is an example of model-driven development where we basically specify only the domain logic and the engine takes care of the rest, which is all the types of queries we can make, and we'll look at that in a bit. And this is basically a Hasura application. The code on the right compiles down to Hasura metadata. But let's focus on what exactly we've defined over here and how that helps us build an API. So first we need to define the schema, and the schema is very simple over here. There's users and there's tasks, and the task table has a user ID field and a user has many tasks. And then we go ahead and define the metadata that the engine needs to generate an API. And we say user has many tasks. Now we can do user.tasks. We say a task belongs to a user. Now we can do a task.user. And then we have permissions. And this is actually interesting and quite unique to Hasura in the sense that permissions are defined at the model level. Let's look at select permissions briefly. So we say a user can select a signed in user. Now, every signed in user has an ID, and that ID is represented by the X Hasura user ID. And we're saying that the signed in user can select any one of these users if the predicate is true, and the predicate is if that user's ID is equal to the signed in user's ID. So this actually becomes the way to complete access control on the model. Let's look at another example. We say tasks, and we say a user can only see their own task, which basically mean task.userid, the user ID field on the task model, should be the signed in user ID. And similarly, we've defined the other permissions as well. So the cool thing over here is what's the minimum amount of stuff we can define and get away with. I mean, we're in the age where you feed the minimum description of your domain to something like ChatGPT and get a complete application. And so what does that minimum description really look like? And this is the Hasura way, and the Hasura way is the Hasura metadata. Let's look at some of the queries that we can already begin to write with this API. Now, this is the complete API, mind you. This defines the complete API already. We can ask for tasks. Now, I'm going to switch back and forth between two kinds of users. One is an admin user, one is a signed in user. Hasura has the ability to run queries as an admin user. And an admin user, basically, none of these permission predicates will apply. Which basically means the admin user can access all data and update all data. But for a signed-in user, they will apply. Let's look at the first query, tasks. It says tasks ordered by created at descending, limit 10. Now, if I was a signed-in user, interestingly, this would only give me that user's tasks. And how this sort of works in Hasura is, if we go back to the permission, we look at the select permission, and the predicate is user ID is equal to the signed-in user ID. And you can sort of imagine on a Postgres database, for example, if you have select star from tasks, the Hasura GraphQL engine basically compiles that GraphQL down into SQL queries that contain the authorization predicates. So instead of select star from tasks, you might have something like select star from tasks where the user ID is equal to that instance of the signed-in user ID. So that's kind of cool because now every signed-in user has this same query but receives a completely different set of tasks, almost like the database itself was user-specific. On the other hand, if an admin user was to run this query, then they would get back all the user's tasks, of course, sorted and limited in this fashion. And these are the fields that they get back. This is basic GraphQL. Let's move on to example number 2. Now here I'm asking for specific user's tasks. I'm saying, give me the user where the ID is equal to some specific ID. And for that user, give me their name and the tasks. Again, ordered by create at descending. And for each task over there, give me the ID, title, and body. So if the signed in user If we took the sign in user and that user's ID was placed in this user ID field, we would get back the data. But let's say you're a different user signed in and this ID was different, then this would actually not return any data, because the where condition over here, if we look at the select, so this is basically doing a select on users where the ID is equal to a particular user ID, and that's going to be sort of joined or composed with this predicate, which says the ID must be the signed in user ID. So you can sort of imagine that if a user tried getting the data for a different user, if a sign-in user tried getting data for a different user, they would not be able to retrieve that data. But for the sign-in user, they'd get back all this information in one shot. The API also has immediately sets up the insert and update queries that look like this. Insert, you can do inserting one object, multiple objects at the same time. You can return the number of affected rows and also return the actual database rows. So for example, over here, we don't specify the ID on insert, but the database gives that for us as a default value and we get it back. And then we can do something interesting with that ID. We can go ahead and update that task and say, okay, if that ID is equal, let's take a task, and if the ID is equal to something, set, update the title, or change the title. We could also do something like transfer all of one user's tasks to another user's tasks. So you say where the user ID is equal to one ID, set the user ID to another user ID. Now, if any signed in user tried running this would not work. Why is that? Because a signed in user, remember, they can only access tasks where the user ID is equal to their own signed in user ID, and they can only update tasks and set the user ID to their own user ID again. But this is something an admin could definitely do. An admin could run this query and actually transfer all of one user's task to another. So another cool feature over here is subscriptions. Now, any query, in fact, can be turned into a subscription. Or you just change this query over here and you say subscription, and then you get a subscription to that data that's live pretty much. And that's kind of cool because a lot of stuff is now handled for you under the covers. All of the authorization stuff continues to work. Let's look at an example of a leaderboard. Let's say the admin was running this, and this says users order by tasks aggregate count. This basically gives me all the users with each user's count of tasks, like how many tasks each user has, and then also sorts them and puts the users with the most tasks at the top of the list. So that's what this is doing, and it's a subscription, mind you. So as another user might go ahead and sign into the system and create a task, delete a task, update their tasks, and so on, this subscription will continue to be updated. And so a client could actually subscribe to this and have a reactive UI that tracks this leaderboard in real time. And all right, so this is all the stuff Hasura engine gives us, and all we've basically done is defined this stuff, which is the models. Again, we know the shapes of the models, which is basically the types, the relations, and the permissions. And the cool thing over here is when we sort of build out our domain, we only really need to focus on the logic that goes into that domain. We're not really thinking about how the data is going to be accessed, which is in fact what the promise of GraphQL was always, until we sort of got to a sorry state where people are actually handwriting their own resolvers. Now that doesn't really decouple the client from the server at all. And over here, we have a domain that's completely described, permissions that are completely described on a role-based basis. And we haven't even begun to think of how our client's going to access the data yet. And but in spite of that, we can be confident that the API generated can actually be shared with client applications already, because our permissions are so good that however we access that data, whatever the query that comes in, it's going to respect our domain logic. And yeah, I think this is a cool way of defining applications, define the models, define the domain, define the logic that really adds value, and then let an engine like Hasura figure out the rest and build your whole API. All right, so I hope to generate a whole series of this. This has been the foundation ideas for model-driven development, and I will see you in the next one.